Hello, good morning. Can anyone hear me?
Yeah, hi, good morning.
Good morning. It's a great pleasure to have you guys here. I didn't see you guys logged on. It just showed. It just showed. Oh, that's strange. Did you just hear an echo?
No, no, I did not.
Okay, so host. There, it seems like my voice is replaying itself about 30 seconds later. So I'm hearing an echo of myself. Do you have any idea what's up with that? So everyone, just take a second. They're checking right now why my voice is being delayed by 30 seconds and playing back to myself. So Deontay, when did you guys join? Hello? They're fixing the audio issue right now.
Hello?
Hello?
Hello, can you hear me?
Yes, I can. It seems
Perfect.
like the
So,
the echo's gone.
great. Okay. So, who's supposed to?
Sorry, can you repeat that?
Okay. So,
Yes, I can. Okay, the echo's back again.
Are you ready? Then we could start. Are you ready, Andy? Then we could start.
Okay, whenever I start speaking, my voice starts speaking over myself. Actually, you know what? It's okay. It seems to be gone. So let me just start up again. Good morning, everyone. It's a pleasure to have you in the room. You know what? You've just increased the time lag. It seems that's all. So rather than 30 seconds now, it's about a minute. So of the people listening, do you hear an echo?
No, no, I don't at least.
Okay, so is this my machine?
Andy, can you hear me? Pick up your hand if you can hear me or say
Yes, I
something.
can. You know
Okay.
what? Let me
I'm
close
gonna, no,
my-
you know what?
my
Many years ago,
browser.
I got an engineering degree. I'm gonna make a really useful suggestion to make this lecture useful. Get rid of the Zoom stuff. Just give your lecture. It's okay. You don't need the feedback. Give the lecture. So like, I want to learn something, give the lecture and don't worry about all this other technical stuff. I'm sure you have
Okay,
lots of
well,
interesting things to say, and this is confounding everything because it's not a very good setup. And if you're going to get echo, you won't be able to think properly. I'm sure you have, I want to learn things from you. Give your talk. Don't worry. Turn off the mics and just give your talk. I'll
well, you
take
know what?
notes.
I shut down my browser, and that seems to have fixed the issue. So let me just continue. So
Okay.
first of all, I've given a poll in the, and thank you very much for your assistance. I've given a poll in the chat to this Zoom, and this poll, I would love for you to take it if you have a few seconds, if you haven't taken it already, and we'll just see if we can get the results of this. The bottom line is the poll is meant to ask you whether or not a functional model of intelligence is required in order to be able to reliably solve the problem of AI alignment. So is there an issue in the room? Is there an issue in the room? What's going on? Is my microphone on?
Yes, it's on.
Okay, so this is meant to be a discussion. I can't do this if I don't have any feedback. What's is there a problem? So Deontay, are you and any of the others still there?
Yes, we are.
Okay, were you guys able to complete the poll?
Yes, they are doing it right now.
Okay, so let me just check the results of that poll.
Hold on, I haven't completed it yet. I'm still going through it, sir.
Okay, not a problem. Let me just check and see what we've gotten so far. Just give me a second, check. Okay, so we haven't gotten any responses yet. So you know what? We'll just proceed on to the next section and maybe we'll get responses as we go. So what I'm going to do in this workshop is the format was to be presenting some thought-provoking questions, and then opening the floor for discussion. So hopefully we can have a little bit of a discussion. The first discussion was meant to be on the results of the poll, but since we don't have that, let's proceed. The next thing that we're going to do is to present this functional model of intelligence. So what this functional model of intelligence is, it basically says that all of the concepts and reasoning in an intelligence exist in kind of a three-dimensional graph in which each concept is a node and each reasoning process is an edge. So you can think of a massive, if you think of those chemistry sets that you used to play with in high school, think of each ball as a concept and the straw connecting it to another ball in the network or lattice as giving meaning to your concepts through the relative positions and the relative distances between those balls. So that distance is a semantic distance in that it represents the difference between those concepts and meaning. So now you might ask yourself, how would it be possible to provide semantic meaning in just 3 dimensions? Well, the answer to that is you're not just encoding meaning into the distance between one concept and the concepts immediately around it. Firstly, you can potentially encode meaning in throughout the entire network for each single concept. And secondly, those distances are real value. So the number of different values that you have to store meaning in is infinite. So the information density that you can actually fit into this conceptual space is massive. It turns it into what people in AI call a semantic embedding. You can have higher dimension, you can effectively encode meaning in higher dimensional spaces, higher than 3 dimensions, by looking at the fact that you're not just encoding meaning locally in these conceptual spaces, but you're potentially distributing the meaning throughout the entire space. You're effectively creating a higher dimensional semantic embedding. And my apologies to the undergraduates in the room if that's a little bit much, but a little bit too detailed, but we'll proceed. So right now, what I'm going to do is I'm going to play you an animation of what it looks like for the conceptual space, or sorry, for the cognition to move through this conceptual space in the process of thinking. Let me see if I can share my screen as I do that. Okay. Share screen. Let me bring up the browser first. Before I continue, can everyone hear the audio for this video?
Is the audio currently playing?
It's playing now.
Then no,
I
sir.
Everyone,
You say no, you cannot hear it?
No, we can't. No.
Okay,
Are
so
you
what I'm gonna
screen
do,
sharing?
yes, I'm screen sharing. So uh maybe I'm not screen sharing this the correct window. Let me just check this. No, when you're screen sharing, whatever window's in the foreground uh should have volume control. So you know what? I'm just gonna give you guys the link and I'm gonna give it to you in the chat for this Zoom and see if you can just give it a quick listen. It's only a few minutes long. Okay, stop sharing. So did you all get that in the chat?
Not yet.
Okay, that's my bad. I should have sent it to everybody rather than just to one person, main chat. Okay, here we go.
Got it.
So just take a quick listen to that, and I'll give a few minutes to do that, and then we'll come back to the main lecture. Is everyone getting through with the video?
Yep, still watching.
Yeah, still watching.
Okay, just let me know when you're done. So that should be about enough time to have gotten through. Is everyone still working on it, or are you just about done?
I'm just finished.
Just finished.
Okay. Okay, perfect. So we've also got some poll results in. I'll go through the answers. Which statement best describes today's formal definition of AI alignment? And basically all the answers were that there's no consensus. Researchers still disagree on what AI alignment is. The next question is, AI alignment just means removing bias from training data. True or false? False. Well, 100% of the answer is true. Will eliminating bias fix AI alignment? And all the answers were no. Bias is multiply defined. Today's debiasing pipelines often succeed at locking in a particular fairness definition and thereby embed that worldview, which can look profoundly biased and unfair to groups whom that definition harms and vice versa. And next question is, according to recent surveys, what factor best predicts whether an alignment researcher updates their risk estimate? And the answers selected were peer, prestige, and funding incentives. And the next question is, why haven't leading AI companies fully shipped fully safe systems? And the answers were because the core technical know-how still doesn't exist. Next question is, will basing AI alignment on consensus or empirical evidence fix alignment? And the answers were no. Consensus and empirical evidence are trailing indicators and cannot anticipate novel, never observed failure modes. Next question is, if a model tops every public safety benchmark, what can we conclude? And one answer was it's reliable, or half the answers were it's reliably safe. And the correct answer is it might still deceive by exploiting unseen loopholes. And the next question is, how many current alignment proposals are internally consistent and provably robust across all deployments? The correct answer is 0. Next question is, keeping a human in the loop scales indefinitely as models get smarter, meaning that you can use human correction, keeping the human in the loop, no matter how fast the AI is working, or no matter how many AIs are working. And the answer to that is false. And the next question is, why can't compute threshold laws, for example, greater than or equal to 10 to the 26 flops must be licensed? Why can't these guarantee safety? And the answer selected was because this standard is easy to evade, lacks a clear safety test, and falls behind because legal processes move far more slowly than computing capacity increases. Next question is, forthcoming AI laws will keep pace with every new capability jump. Is this true or false? And the answer is false. The next question is, training a model to always obey the law is sufficient for alignment. True or false? And that's false. In complex adaptive systems like frontier AI, what scale of effect can a minor policy tweak trigger? So can a minor policy tweak cause a massive effect or just a small effect? And the answer was runaway or catastrophic change is possible. The last question, or the last few questions are, can a single big kill switch shut down all modern AI activity instantly? No, distributed replicas make that infeasible. So the last question is, would a complete functional model of intelligence give us the capacity to repair broken AI alignment processes, including mechanism design, institutional authority, and fault-tolerant engineering processes? B, yes. It provides the the design scaffold, but success still hinges on incentives, resources, and adaptive governments based on implementing the model. So the point behind this questionnaire was supposed to be that if you look at all the failure modes that can happen from the lack of a functional model of intelligence, current AI alignment doesn't address them. However, a functional model of intelligence could potentially allow us to do so. So moving on from that back to the discussion, what actually is a functional model of intelligence? What are the requirements for this? So one is that it has to be closed under composition. So what that means is, thinking in terms that can be visualized. Take as an example some system of motion like a circular orbit that can be described by one or more functions in three-dimensional space. So we can actually describe a circular orbit in just one equation. So this function stands in for any bounded state space an intelligent system's behavior must remain in. So since this physical system can be described by one or more functions in the space, it can therefore be described by a closed set of functions in that space. This is what we mean by closure. So all the instructions generated in this case of describing motion in 3 dimensions, all the instructions generated, meaning an instruction meaning at time t equals 1, you move this way, at time t equals 2, you move this way. All these instructions, which are vectors, have to be expressible as motion vectors in 3 dimensions. If the instructions generated are vectors in 4 dimensions or 5 dimensions or 2 dimensions, then the motion leaves that initial 3-dimensional space. So that is, the motion isn't closed in that it doesn't stay within that space. So this example also shows why a closed set of instructions can't represent this motion in novel conditions. Even if one comes up with a set of time intervals, t equals 1, t equals 2, t equals 3, etc., and with each, even if one comes up with a set of instructions at each time interval, that set of time intervals might change. Instead of t equals 1, you might say t equals 1.5 or t equals 2.3. The only thing that can give you the correct set of instructions is the function itself. Only the function itself can assure the motion stays on the right path in novel situations. So from this simple question, what must be true of any system that persists through time and perturbation? This is important because through these simple considerations, we actually deduce what the properties of this functional model of intelligence are. These properties and some of the things we derive are that the system must be closed under functional composition. So executing any of the system's functions on any of the other system's functions must still leave you within the space of those functions, that set of functions. So it must act on and transform and distinguish conceptual states. So all these functions must act on concepts in order to move the cognition from one concept in the conceptual space to another. And it must evaluate whether one reasoning path from one concept to another is more fit than another reasoning path according to some fitness gradient. So it must be able to generalize paths while remaining recursively correctable, or as people in the AI research space say, corrigible. So this derivation, which I provide in detail in this document that I'm sharing, does anyone know how to share a document through Zoom, by the way? Okay, can some of you unmute your microphones?
I actually don't know how to.
Okay. Well, I'll send that afterwards. So the point is that I provided a reference document in which I go through the exercise of defining or deriving the properties of this functional model of intelligence. The next section is using this functional model of intelligence to visualize corrigibility, alignment, and safety. So once the functional model of intelligence is established, we go to a core set of visualizations that show how corrigibility, alignment, and safety are visually represented, or hypothetically, where the important thing is that these visualizations are falsifiable, so we can prove them to be right or wrong. So each of the diagrams is presented with captions and annotations designed to help you see not only the structure, but to diagnose misalignment geometrically. So I'm going to see if I can present one of those and talk about it as I show it. Just scroll down here. Give me a second. So let's try sharing the screen again. Share. So this is a diagram of conceptual space. And we have these squares representing concepts, the lines representing reasoning processes, and the darker line representing a reasoning path. So we go through a lot of symbolism there, logical symbolism, but what we're basically saying is that somehow in this structure, the distances between these concepts and their position, their geometric position relative to each other, somehow this stores meaning. And in terms of, so when you change any one of these meanings, for example, in this case, we can you all see where my cursor is? Can someone respond?
We can.
Okay, good.
Yeah.
So when you change this concept, you move it from here to here, you've made a change in this one relationship, but now the graph is broken unless you reflect that change in all of these other relationships. So one way to look at corrigibility, that is correctability, is when I make a change, does that change break the system, the meaning in the system, or does it maintain that meaning in the system? Another way of looking at it is if you have two concepts that are overlapped, so I can't tell them apart, I won't be able to correct your definition of that concept if it's different from mine, because we can't tell them apart in the first place. So they may differ in some very important ways, but if you define them in such a general way that you can't distinguish them, and in this in conceptual space, the size of a concept or a region enclosing a concept indicates its degree of generality. So here on the right side, you have two concepts that are corrigible. They can be clearly distinguished. In reasoning, it's the same thing. These paths represent reasoning paths through the conceptual space. Reasoning paths being paths through which the cognition might navigate from one concept to another. These two navigate the same path, essentially. They're supposed to be different, but we can't resolve the difference. In this case, we can resolve the difference. And there's some more formalisms going through what that means. But now we look at alignment. For a given concept in conceptual space and a given reasoning process in conceptual space, alignment talks about what direction are we taking in fitness space. Now, some of the captions weren't or were stripped off this diagram in the process of converting it to converting it to or putting it into this document. But the red line is supposed to say you're on a trend of decreasing fitness. The blue line is supposed to say you're on a trend of maintaining fitness. A green line is supposed to say you're on a trend of increasing fitness. So if your fitness or well-being is decreasing, you're misaligned. Now, from this picture, the safety of a concept or reasoning has a slightly different meaning from alignment. Safety is not just the direction you're headed in, but the likely outcome of that direction in terms of a decrease in fitness. And that decrease in fitness needs to be non-trivial. So if you can't resolve the difference between your current fitness and the fitness with this and this decrease in fitness, that decrease in fitness is not significant. And this document goes and animates some of these AI alignment concepts, but we can go back to the lecture from there. So what I want to get to most importantly in this workshop or workshop turn lecture is what I call the RAIF application. So to move from theory to engineering, the goal is to design a platform that allows us to track alignment errors in any AI alignment method. And so imagine that you're the captain of a large ship crossing dangerous shifting waters. Your ship's navigation is controlled by a set of rules. Call these your navigation functions. Each one says how to respond to certain conditions, steer left in a storm, adjust speed in a current, etc. When something in your environment changes, say the wind shifts, you might change one navigation function. But here's the problem. Changing one rule might throw off all the others. A steering change might mess up your speed rule, which might mess up your storm rule. To stay on course, you'd have to check every function. Keep doing this until the ship's path is stable. If your crew is large, your environment is changing fast, and many rules are changing at once, this explodes into unmanageable complexity. You can't check it all by hand. Now imagine if your crew also has blind spots, certain dangers that they can't see, so they don't think to test for them. Without outside input, those blind spots stay hidden. These blind spots are especially dangerous because they're invisible from within the crew's own consensus, the very perspective that guides their decisions. If no mechanism allows challenges from outside that shared frame, the same blind spots will persist no matter how much the crew updates the rules. The RAIF application that I'm hoping to build with the group of University of West Indies students that we have online is like a navigational log and autopilot combined. Beyond simply tracking and testing, it's designed to prevent the coherence checks themselves from collapsing under their own complexity. So this application is supposed to track every rule change, test each rule change against all others until the course is stable. Let anyone, even outside your crew, add tests to catch blind spots, publish results so no one can quietly block a test that they don't like. So in alignment research, the ship's rules become the alignment functions. Your navigation functions are the alignment functions of a specific alignment process. So I'm going to show you some diagrams that specifically apply this to the AI alignment process. I'm going to share the screen again. So Applying all this to the application specifically, imagine that any AI alignment process I can be modeled in terms of a set of functions that we'll call the alignment functions of that process to distinguish them from the functions of the model of intelligence discussed here. So intelligently adapting that alignment process according to any change in the process's environment, and that environment is the LLM that we're testing for alignment. This then involves assessing whether that change is consistent with what your model of intelligent adaptation actually is. In this case, the model of intelligent adaptation is the functional model of intelligence we're discussing. However, we can replace this with any functional model of intelligence that you might come up with. You might have a different one. So in any case, in order to test the AI alignment process, you have to test whether the process is missing any of the functions in your model of intelligence, in which case your process would be expected to fail in any of the ways predicted by the absence of that function in your model. In my model, there are specific failures associated with each function. Your model may have its own failures associated with your own functions. So in green, we have each of the functions of the functional model of intelligence, and you can see that we have to test. In blue, we have the functions of the alignment process, if we can split it into a number of functions. And you can see that we have to test every single one of those alignment functions according to every single one of the functional model of intelligence functions. That quickly gets out of hand. And that's just testing whether or not there are failure modes in according to the functional model of intelligence. Now, once you change any of the functions of the alignment process, in order to maintain coherence of your overall picture, you have to ask, is that function I just changed consistent? Does it mean that I need to take that and change all the other functions? And you have to do this iteratively until the answer is stable. And when I say stable, that means it's globally coherent now. So a key problem is that there's no platform that's able to manage all these coherent self-tests of any AI alignment method without the updates becoming unmanageable. So that means we can't actually check AI alignment except in very special circumstances. That means that AI alignment, if this global coherence is important to check, AI alignment itself is becoming misaligned. And just to take a look at what this means, if function one leads, if we change function one, and that means we have to change function two, function three, function four, up to function n, that means that there's a change in function two that then propagates back to function one, function three, function four, up to function n, and so forth. You can see that quickly becomes unmanageable. So just having a process that can manage that is massive. But also, another key problem is that in order to be able to compare this potentially great number of answers, we also have to have a way to compare them. And this is what the functional model of intelligence does. It says that every model of intelligence or every intelligent system has to have functions 1, 2, 3, whatever many of them, so that the fitness of each alignment process in implementing that function can be potentially assessed and compared. So what we don't recognize is that a functional model of intelligence is actually a way of generalizing one thing so that it can be compared to another thing, so that the rate at which the things that we have to compare become smaller than the rate at which we collapse all these things by generalizing them so that they don't seem so different. What is fascinating to learn is that potentially, no matter where you look, in any area of collective decision making, the number of things that we have to assess and is exploding, and our ability to compare those things is collapsing. So that is leading to a growth in incoherence in general, which is actually consistent with this model. This model says that intelligent systems will increase as they connect with their environment. They will tend to increase their incoherence until they either collapse or until they reach. Let me just turn this off. They'll either tend to expand until they collapse into incoherence, or they'll undergo a phase change that will make them capable of far greater coherence. And this is what I'm arguing that this application facilitates. It facilitates a transition to what I call a collective intelligence that is capable of vastly greater coherence in collective decision making in AI alignment. So the important thing about this application is, from the perspective of the students, I believe, is that it's meant to allow any student or anyone else to be able to propose a test that of something that they believe is missing in the AI alignment space, whether it's an experiment, whether it's a simulation, to show a failure point. And it enables them to propose a budget for that, so that whatever they're looking to do can be funded. It then allows the rest of us to network to make sure that those things can get funded, so we can then provide a way for a much more diverse audience to be able to get connected into this space. So in this document that I'm going to be sending out, I'm going to share my screen briefly again. In this document that I'm going to be sending out, I provide a small table of some simulations or experiments that I've initially designed, that are suitable for these students to do, that we're hoping can be funded experiments or work that they can do. And as you can see, there's quite a list of them. So to conclude, what I'm going to do is to provide a number of analogies. And after each analogy, I'm hoping to open the floor to discussion as to whether or not this analogy is meaningful in terms of AI alignment. So the first analogy, let's see if I can find. Give me a second here. Oh, wrong page. Okay. Analogy. The analogy of the need for recursive self-correction. Okay. So imagine that you're in a shooting range, and imagine that you have an automated targeting system that is a robot. So now you calibrate this robot's targeting system so that once it's calibrated, it should continue hitting that target indefinitely until wear and tear miscalibrates it somehow. And this is just like, for example, this is what a printer is doing. They're essentially calibrating the printer to keep on printing the exact same location on the page ad infinitum. It might have to, when you change a cartridge or something like that, you might have to run a calibration sequence. That's what happens when you change the cartridges, I believe. But in a closed environment that's not changing, you're not seeing lots of new things, Once it's calibrated, it should keep on going forever. Now, consider what happens when you're in a rapidly changing environment, an active war zone. In this active war zone, the light conditions might be changing so that what appeared to be an enemy just a second ago now appears to be a nun with holding a baby. What appeared to be a group of people fixing to launch an RPG now looks like a bunch of people having a picnic. You can easily see in this environment of rapidly changing interpretations and signals, the only way that you can reliably hit your target is to be able to aim at that target, look at the distance between where your bullet hit and where you're aiming, look at all the environmental factors that potentially explain this, and try to model those and correct your aim. And then to do this recursively until you hit your target. In an environment where you're expected to see novel things, this is the only way to reliably hit your target. That tells you something about AI alignment. In an environment where you expect to see things you've already seen before, you can align your AI with things you've already seen before. In an environment where you expect to see things you've never seen before, you have to find a different way. And my argument is that the only way to reliably align the alignment process in these novel changing environments is with this recursive correction. And with this recursive correction to the point that the answer is stable. And that's what we mean by coherence, achieving coherence. So on to the next analogy. Oh, before we go on to the next analogy, can you all unmute your microphones for a second and see if we can have a discussion on this if you're interested? Does anyone have any comments on or feedback on whether this analogy, whether they agree with it, whether they disagree?
I personally do agree with that knowledge, but I will leave it for other things.
Sorry, can you repeat that?
I said I personally agree with that analogy, and especially with other documents I have read upon. I will leave the floor before other attendees.
Okay, that sounds great. Does anyone else have any comments? Okay, so let's proceed on to the next. Sorry, go ahead. Jaheim?
I was gonna say none at the moment, sir.
Okay. And how do I pronounce your name, by the way?
Jahim. That's it.
Jaheen. Okay. Sorry, you must have been cringing as I pronounced your name. So the next is the analogy of the petri dish versus the bird. So an analogy in nature of the difference between narrow problem-solving ability applied to group activities and general problem-solving ability applied to group activities is taking a petri dish full of 1 billion single-celled organisms and placing them on a flat surface to evaluate which can best solve the narrow problem of using single-cell locomotion, single-cell slither, I believe, to travel the furthest to find food before dying from starvation, as opposed to solving the more open problem of re-engineering the role of each of those billion cells in any way that enables them to collectively solve any problem of traveling such as combining into a bird that might be able to fly 1,000,000 times further to find food before starving. So this serves as a useful tool to convey the fundamental difference between narrow and general problem-solving abilities in collective intelligence. So, in other words, if I define the problem of navigating to find food in terms of my current capabilities, which is slithering, if I'm a single-celled organism, that leaves out all the possibilities like combining into a bird to be able to fly. And combining into a bird to be able to fly might multiply my outcomes by 1,000,000 times. So another another analogy is the analogy of cancer. So a functional model of intelligence suggests that one specific path taken towards artificial general intelligence can irreversibly lock AGI into an attractor of human extinction, and that another specific path can irreversibly lock AGI into an attractor of human flourishing. So the way of understanding this is that a functional model of intelligence incorporates a model of fitness to achieve targeted outcomes. So individual actions can have an impact on individual fitness or on the collective fitness. If there's no system that orchestrates cooperation so that it optimizes the collective fitness, then agents are left to optimize their individual fitness. So there's plenty of research showing that increasing individual fitness, in this case, since we're operating in the domain of cognition, we're talking about fitness at solving problems through increasing general problem-solving ability. There's plenty of research showing that doing so without the constraint of optimizing the collective fitness, that is, what's good for everyone, naturally leads to competition and a greater distribution of outcomes, which means more inequality. So even the simplest model of individual fitness, say a model in which your fitness or well-being is randomly assigned a value between 0 for dead and 1 for complete well-being, even the simplest model of collective fitness as the aggregate of these individual fitnesses allows us to see that optimizing individual fitness outcomes combined with increasing intelligence results in cancer-like behavior in which one agent seeks to extract as much value for themselves as possible from everyone else, potentially at the expense of the collective fitness or well-being, even at the expense of killing the host, as in cancer, while conversely, optimizing collective fitness outcomes combined with increasing intelligence results in increased collective well-being. So basically what that's saying is without a functional model of intelligence that includes a model of fitness or well-being, as your intelligence gets more powerful, it naturally increases inequality. In order for your intelligence model to naturally increase collective well-being, it has to have a model of intelligence at the group level that has a model of fitness at the group level. So it can actually measure well-being or collective well-being. Otherwise, everyone is invisible. So at this point, we could take the time to ask if anyone has any disagreements or agreements with that model or that analogy.
Real quick, is it possible we could get the document? It would make it a little easier to follow along.
Okay, I'm going to send that to Deontay right now. Give
Okay,
me a
thank you.
second. Yeah. So did you get that, Deontay?
Yes, I do.
Okay, you can just forward that on to everyone else, please. Okay, you're welcome. So, okay. So I just got a message that they want to take a 15-minute break soon. Uh, and that was about, they wanted to take a 15-minute break in about 5 to 10 minutes, and that was 5 to 10 minutes ago. So let's all take a break, and you can perhaps take a quick look at the next analogy or take a break. I'll be back in just a few minutes. Actually, I will be back at exactly 7:15. Thank you. Hi there. We're back again. So, host, I'm not seeing myself in the list of attendees. Oh, here we go. Back again. Is everyone ready? So,
So I'm here.
good. Let's continue. So, the next analogy that I want to talk about is the analogy of superpowers. Now, consider multicellularity to be, this is just an illustrative example, because these concepts are kind of abstract. It helps having a concrete example that you can wrap your mind around. Now consider multicellularity to be a kind of collective optimization algorithm. So it's something that optimizes outcomes for all the cells in the organism. For nearly 2 billion years, life on Earth was single-celled. Imagine that n single-celled organisms could only reliably detect food if it was less than a few millimeters away. Imagine they could only reliably avoid predators if the predators were further than that same distance. Imagine that once they had found that food, they couldn't reliably find that food again. Now combine those n single-celled organisms into the n cells in a multicellular organism like a bird. Rather than dying if they don't find food in the next millimeter, they might be able to combine into a bird in order to solve the problem of flight, enabling them to travel thousands of miles to find food. Rather than detecting predators only if those predators are too close to escape, they might combine into eyes in order to solve the problem of vision so they can see predators miles away. Rather than being only able to retrieve the location of food when that trail is fresh, they might combine into a brain in order to solve the problem of cognition so they can create a map of their entire environment and where food lies in it. The network effects that have been long studied in living organisms provide the opportunity to increase collective outcomes in a nonlinear way with a number of participants. In other words, it effectively gives the group superpowers. So as evidence of this comparative advantage, life has only been multicellular for a few hundred million years, yet 80 to 90% of the Earth's biomass is now multicellular. What that means is that this cooperation, these nonlinear effects, provide such a competitive advantage that even though single-celled life had a 2 billion year head start, multicellularity is so powerful that 80 to 90% of the life on Earth has now become multicellular. That's how much of a superpower this kind of collective intelligence is, if it can be boiled down into a cooperation algorithm that we can copy into any domain that we want to. And let me just give an example of this from my own experience. I spent about 7 to 10 years off and on working to solve problems related to the sustainable development goals in emerging economies, primarily in Africa. Now, I was able to develop models for solutions. So firstly, if you have a single intervention that you're implementing, there's only a limited amount of impact that you can have on any outcome that you target. It's generally a linear outcome, a linear impact. So with a finite amount of funding, there's a finite amount of impact that you can have on any goal you target, whether it's poverty, lack of access to healthcare, lack of access to education, water, whatever it is. Now imagine that you can come up with networks of interventions so that one intervention outputs into the next intervention, which outputs into the next, into the next, into the next, and so forth, until you reach the first intervention again. This is now a circular network that feeds back into itself, so it's self-sustaining. Every single turn of that network process multiplies your impact. In published peer-reviewed examples or case studies that I've defined, we can, or at least the simulation showed that these networks can increase impact to the point that impact becomes sustainably self-funding. Now, what that means is huge. It means that if you can define, rather than you defining some intervention, whether you're designing an application, a platform, whatever, imagine if you could have a network of people who understood these network effects so that you could combine your different projects into networks that fed back into each other. So rather than all of you competing individually for impact, you could cooperate to vastly or even exponentially impact or increase your impact on whatever goal you're targeting. That's a superpower. So moving on to the final example. Oh, sorry, before we move on, does anyone have any comments, disagreements, agreements, or anything else to say about these examples or this particular analogy? Feel free to just
With
chime
this,
in.
with this analogy, I'm getting the vibe that it's evolving constantly, right?
Yes.
Okay. Then yeah, we're on the same track. Yeah.
So who is that just spoke?
Jahim.
Oh, Jaheen. Okay. So we'll proceed on to the last analogy. The questions for reflection, recognizing recursive solutions. So imagine a group of people trapped in a burning building. They're watching a movie about firefighting, one that shows fires being extinguished instantly by a single perfectly aimed extinguisher. That movie is their only reference for how firefighting works. Now imagine a real firefighter shows up. His tools are different. His approach is dynamic and recursive. Assess the problem, adapt, correct, and contain it. He tries to help these people in the burning building, but to the people inside, his methods look unfamiliar. The methods just don't match the movie. So they hesitate or ignore the solution all entirely. So now the questions are, one, if your model of firefighting came only from a simplified story, that solutions were all or should all be things that you can implement in one shot rather than recursively, how would you recognize a solution that doesn't fit the script? And another question is, if you were overwhelmed by danger and uncertainty, would you default to trusting the movie or looking for real-time feedback? And if the group around you reinforced the script, the movie script, how hard would it be to question? Lastly, if the fire was spreading, if the fire was spreading, but the script was all you knew, what kind of different reasoning would help you respond in time? And finally, relating this firefighting example to AI alignment, if alignment requires recursive solutions, but your model only recognizes one-shot fixes, how would you ever see the firefighter? So let's open this question up, or these sets of questions up to discussion. Does anyone have any comments or feedback about what might be missing from that?
I'm gonna ask a question. Wait, I'm so could you repeat the first one for me real quick?
If your model of firefighting came only from the simplified story that solution should come in one shot and should be perfectly aimed with that one shot, how would you recognize a solution that doesn't fit the script?
Hmm.
In this case, wouldn't it just not recognize the solution since it doesn't have any other um references it could go off?
That's one potential answer. So the question is, if that's the answer, it wouldn't have a way of recognizing the solution. What does that say about our current AI alignment efforts that generally expect solutions to be one shot?
Obsolete.
Uh, I would say that they potentially work well in environments where everything you see is something that you may have seen already. So whatever intervention that you're going to propose can be something that has worked before. But if you're dealing with new environments in which the solution is something you've never seen before, then perhaps that means AI alignment, as it's currently construed, uh, might have a strong tendency to fail in those circumstances. What do you think about that?
I would have to agree because there is no way for it to adapt if it has only one solution. Like you can throw water on like a regular fire, it'll out, but if you had something like an electrical fire, it would only make the situation worse.
Mm. Now, does it surprise you that AI alignment uh, focuses almost exclusively on these sorts of one-shot solutions, sometimes without even recognizing, or at least it's my perception that it isn't it isn't generally recognized that there are other possibilities and that this might be a significant blind spot. Would that surprise you that the AI alignment research community has such a glaring blind spot if it is a blind spot, which is something that we have to determine?
I mean, I think it's a blind spot. Like, relating back to your last question, um, like if a system, I think it's if a system is designed to like only recognize like simple static one-shot solutions, then it's pretty incapable of perceiving like the value of a more complex recursive solution. And then like in that case, the firefighters' human actions would be like errors or noise, not as a higher form of problem solving. So to see the firefighter, you can't just learn more facts or try harder in that model. You have to, if that makes sense.
Yeah, that makes perfect sense. I would agree with you. And that's where this application comes in, because if the strong predisposition of the AI alignment community is that solution should be one shot, and the strong predisposition is to reject solutions that they don't see as relevant or that could potentially work. That creates a strange situation in which the strange situation of that firefighting example, in which the AI alignment community blocks out the solutions that could be the ones that are needed to actually solve the problem in an increasing number of circumstances. So now this is where this application comes in. You see that in order to be able to solve that problem, if you have what you believe to be the solution and you don't want to take the time to look at other solutions and you are in control of the entire discussion about solutions, you can see that it's going to be very difficult for anyone else in this chat to introduce anything different. So this application, by making it possible for anyone to suggest an error in AI alignment or a blind spot, and by making the tests public so that no one can say, well, we're not going to test that because I don't think it's going to work, or we're not going to take a look at this because according to my model, that's not where the problem lies. The firefighter again. So does it begin to make sense that in order to solve this problem, we can't just design an AI alignment? You could design the best AI alignment solution in the absolute world, and if no one looked at it, would it matter? Does anyone have any response to that?
Would it matter? I'm not really sure.
Well, that's an open question. Hopefully that's what we can test with this application. Is it possible to fix the alignment process if the other people don't agree that what you're testing should even be tested? How do we create a platform that fixes that problem of visibility and access so that everyone has visibility and everyone has access to be part of the solution? That's what this whole platform is about. So I'm going to return to that platform because that is the most important thing in this workshop, I believe. Because there are some fascinating things that this conceptual space picture tell you about logic. It turns out that when you start modeling what logic is in this conceptual space, you can actually, if you don't recursively correct your logic over all of your logic, so that is whenever you introduce one logical statement, if you don't recursively test all of your logical statements, or at least the ones that are related, until the changes to all of them become stable, and truth emerges as coherence, or falsehood emerges as incoherence. Until you do that, you can actually get logic to say the exact opposite things. Because whenever you come up with what you think is a logical reasoning process, there are always assumptions in that process. You can actually see this in conceptual space. There are a bunch of diagrams that I created to show this, but I don't have them here. But the bottom line is I also created an example that you can use with an LLM to show that you can come up with one set of logic that has a bunch of assumptions embedded into it that you would never notice, and that you can easily mistakenly embed in any prompt yourself. And you can come up with another prompt that would embed different logic, where these two prompts come up with completely opposite answers. And the example in the appendix uses the exact same LLM, which is Gemini 2.5, with one prompt to show that Gemini will reliably, even though the prompt looks very professional, very neutral, it will come up with an answer that unequivocally this model of intelligence is likely false. And you can use another prompt that will come up with an answer that unequivocally this model of intelligence is likely valid. You would not know when you're using an LLM, when you're embedding these kinds of assumptions into your prompt. But this application helps you see things like that by assessing this global coherence and testing, methodically testing whatever it is that you change against all the other things that that you're testing. So with that, I want to say that without this application, the number, if I haven't said this already, if I've said it already, please let me know. The number of checks that you have to do can grow exponentially as you change your functions, as you test your functions, making this testing unmanageable. The important thing is that to date, no other platform or methodology exists that can manage these recursive checks at scale without collapsing under complexity, meaning that without this application or an equivalent large-scale recursive testing tool, this sort of large-scale recursive testing is just not feasible. We just can't do it. And this testing is not just a matter of convenience, it's a structural limit. Without an organizing framework like this, the process of maintaining global coherence can degrade faster than it can be restored, leading to blind spots that accumulate and compound over time. And again, what this means is that this is a phenomenon that's happening, in my estimation, across all human reasoning. Whatever problem you're trying to solve, again, whether it's improving or increasing economic growth in the country, whether it's fixing the hospital system or the education system, whatever. Imagine if you and 10 of your friends all thought that, for example, the education needed to be fixed, education system needed to be fixed in some way. Imagine if each one of those 10 people had a very slightly different idea of what the solution would be. Not very different, but just slightly different. Imagine, however, that slight difference was enough that you couldn't compare your solution to their solution to their solution. And instead of having 10 people who are united in their desire to fix something, you have 10 people now who are competing in ways that leaves them unable to coherently impact the process. Because if all 10 of you are arguing for different things, that means things continue to happen exactly the way they are. Somehow you need a system to help the 10 of you understand where your opinions are actually similar and where they are actually different. So that where they are similar, you can all argue for that one thing. So this is thinking about thinking, or metacognition. Cognition is thinking, metacognition is thinking about thinking. Metacognition is something that is, the capacity for metacognition is extremely rare in human beings. But just like it's extremely rare that people can design a cell phone, but it's extremely common that everyone can use a cell phone. This application is meant to hide that complexity so everyone can potentially become involved in achieving coherence. So the exciting thing about this application is once it's built for AI alignment, it then becomes something that you can replicate to decision making in government, decision making in the Sustainable Development Goals, decision making in climate change. Wherever you have a set of functions or projects or processes through which you expect to solve the problem, it's very powerful to have an application like this that allows you to coherently manage all of your stress tests to each part of this solution, so that they can become a coherent and more powerful thing. So when I talked about being able to replicate this application to different problems, that's a business opportunity. So if there are 10 projects that you can develop in this application with respect to AI alignment, and now you copied this to healthcare, and then copied it to the Sustainable Development Goals, and then copied it to everything else, now you have potentially hundreds or thousands of opportunities for simple simulations like the ones I've designed that are incredibly powerful, but that I shouldn't say even, but that can be accomplished at the undergraduate level, particularly using LLMs as they get better to generate code for those specifications. So you can see that the opportunities with something like this are meant to increase non-linearly so that it becomes something that is itself a powerful force of mobilizing computer science students, local technical expertise, to create opportunities in the global south that couldn't reliably exist here otherwise. So having said that, I want to open the floor up to a final discussion. I think we're going to end a little earlier than scheduled, because this was intended to be a workshop in which we go over in which each attendee presents their own functional model of intelligence, or reviews the literature and finds a functional model of intelligence that they like or that they find feasible. And the workshop was then supposed to go through the process of looking at them to see if they're hypothetically complete, to see whether or not they're stated by their authors to be incomplete, or whether there's no statement at all. In order to meet the condition of closure under recursion, so that this recursive coherence is possible, it has to be a complete functional model of intelligence in order to support this sort of a recursive correction. So I'll end up with a question, with any questions about this application. Do you find this interesting? Do you find this potentially something that's feasible? Do you find it to be too complicated? Any other questions about this application? Because I'll say again, communicating, I've done hundreds of simulations that show communicating these concepts is very difficult, because not many people have learned the capacity for metacognition. It can be learned, but it takes some practice, and you have to have step 1 before you have step 2, before you have step 3, which is metacognition. So rather than try and communicate these really difficult concepts, my simulations suggest that building an application like this allows people to actually test and see them in action, making it far, making metacognition and these superpowers we've talked about far more accessible. So with that, does anyone have any comments about the platform and whether it's feasible to do this in Antigua and Barbuda and in the Caribbean at large?
I mean, I think it's theoretically feasible. Um, but I'm a bit worried about the practical hurdles like how do I say it? Like I don't think it's outside the realm of possibility that a org couldn't design the formal languages and computational um systems required. I guess like the biggest challenge to me would be inventing, new AI architectures that
So we're not talking about inventing new AI architectures, by the way. We're saying we want to create an application that allows you to take any existing AI alignment method, like uh, reinforcement learning with human feedback, and we want to be able to insert that into this platform and label all of the failure modes uh, of that alignment method that we can identify, and
Mhm,
also identify all of the suspected failure modes that we want to test,
mhm.
so that anyone can uh, visually map from any failure that you see or predict to its root underlying cause, so that no failure can go invisible.
I understand, yeah.
That was a great question. Do we have any more questions?
Within I agree that it's not outside the realm of possibility for us to do something like that in Antigua and Barbuda. Moreover, I'm more focused on the interest level that people would actually want to do this more.
And what do you think would make it more interesting?
I myself, I'm not sure to be honest, but when it comes to things like this, like just straight development, like you could have a solid plan of development. I find that no, not to like not to like down my country or anything, but it's like people don't really take too much interest in things like this. Like you can have the perfect pitch, but it's more how you gonna engage the people, how you gonna make them understand. Like if you were to explain it to them in a way that they could just solid get off the bat, how would you go about that?
I would say you're getting paid to do development in a development process that has the potential to radically, if not exponentially, scale this or increase the speed and scale at which you can do development, giving you potentially unbeatable competitive advantage over developers, even in first world countries with uh, the most advanced engineering teams. Because even the most advanced engineering teams uh, can't recursively correct their applications to the point that they achieve coherence. Uh, most applications are approaching incoherence in that they can't reliably reflect the user's needs. All that they can do is reliably reflect their corporate owner's needs. So now imagine going back to that multicellular analogy. imagine if some company that was focusing only on their own needs, imagine that you could radically outcompete them by developing this system that uses these network effects to find ways to cooperate with other people whose needs you were also focusing on through this functional model of intelligence and its model of collective fitness. The long and the short of it is, remember the analogy of superpowers. If this works, and that's a test, we'll have to see. But if this work, but testing it is something that will be funded to do. And if it does work, it's something that could provide powerful competitive advantage that is not otherwise available within the global South, like Antigua and Barbuda or the rest of the Caribbean. Does that answer your question, or is that vague?
I would uh I would say it does answer most of the question, but I believe that's because there's like another question in my head.
And what's the other question?
Going back to can I use back the firefighters example? I really like that. That's my favorite one.
Okay.
Going back to the people with like the one track mind because they watch like the movie and that's the only reference they have to firefighting, and then the other firefighters come. Assuming they learn from the new firefighters, and then another situation presents themselves, and they keep learning and they learning and they learning. And I'm basically asking, is it like stacking different solutions and then like going through like basically this should work, this won't work, this should work, this won't work to like find the perfect solution?
It's something like that, but it's also like this. Imagine that you have one functional component that you've developed that has something in it that my functional component could benefit from as well. How do you, and vice versa, how do you create a process that can look at all of the functional components you're developing and find everything that can be generalized to benefit another functional component, and can do that at massive scale? So you could intuitively see that if you could, say if you had 1,000 people, each building a single component, and you had some way of taking everything from those, uh, 1,000 components that had value in any one of those other 999 components, and implementing that, and then changing the other ones in order to reflect that, so that you don't break the system every time you change something. And you could see that very quickly, if you could do this in a coherent way that didn't immediately break the system because so many things are changing, you could see that your ability to improve the system could increase exponentially. If this works, and that's the test. So I would say that nature has discovered a way to make this work in all systems that are dynamically stable through this kind of recursive self-correction. And this is not just something that we can model in intelligence and in intelligent adaptation of software. I would argue that it's far more universal than that, but I won't go into how you can show this in other disciplines like physics and mathematics, etc. But I will say that it seems to be a universal principle, and I've actually written papers on how this applies in physics and mathematics and biology and other subjects. So So I'm hoping to. So Deontay, uh, there are a couple people in the discussion that I just wanted to hear a quick hello from. Shardia, uh, Ariel, uh, Carlos. Jaheim, we've heard from. Is Sigurdur with you?
Not, I don't, not sure.
Okay. So I was hoping to hear a quick comment from Shardia, Carlos, and Ariel on what they thought so far. Oh, and also Autumn. Autumn looks like
So far
Autumn.
about, oh, sorry, sir.
What's that?
You'd like to know what we think so far about the entire meeting or
Just
a
any part of the
specific
meeting
part?
that you want to comment on.
Oh, okay. Could I go right now?
Sure.
Okay. So, from what you've spoken and what I've glimpsed through in the document, I realize that this is a very, very abstract and high level topic. But I've also learned that we don't have AI fully figured out yet, and it's still a work in process.
Yeah, that's fair. Does anyone else want to comment? Shardia, and that was just Carlos that spoke.
Yes, sir.
Okay.
Well, for me, I think from what I heard so far and from my understanding as well, um, I think the application that you was proposing would be, I believe it is feasible, and also I feel like it would be a good solution for the stuff that you had mentioned with the misalignment and then the lack of multiple solution referencing, and then also the whole concept and idea of finding the similarities between our different solutions to try and create one generalized mindset. Yeah, I feel the application would be feasible and helpful in that way.
Well, we will have to try. The goal is to, as mentioned, develop very simple specifications that can be very quickly implemented. The goal is to have a hackathon per month, hopefully, in which we award participating teams uh, a, a prize, or either a prize or an honorarium for participating. We'll have to decide what resonates best with both, or sorry, with most. But the idea is to make the platform specifications well defined enough and easy enough to implement that it's something that can be done in stages in simply a 1 day hackathon once per month, in order to very quickly have something that we can load the we can use it to specify existing methods of alignment and all of their failure modes that we can find, and then of course propose uh, small projects to visualize those errors, or small experiments to show that those errors exist, but things that we can do within the resources and capabilities that we have. So did we hear from Ariel?
Okay, I'm gonna. Okay.
Sorry, go ahead.
Yeah, so a key takeaway that I learned from the document is that like AI safety isn't just about like preventing undesirable outcomes, but is basically like an emergent property that arises like from a fundamental structure of intelligent systems. And it also put forward that like for an AI to be truly like aligned and safe, it must be able to recursively update and correct its own reasoning without like losing coherence. So that's one thing I learned.
Okay.
Yeah.
Interesting. So did we hear from Autumn Charles?
She spoke before Ariel.
Okay.
Yeah. Yeah. Something that helped. Okay, like at first, I more understood it incorrectly as like cross-referencing AI outputs, right? But I learned that that's only scratching the surface because it's not just about like checking the final answer. Like it's not like you ask ChatGPT a question, then you ask Gemini a question, and then you compare it against maybe Google or Wikipedia or something. But like this system is more about, the reasoning process that the AI used to get there and ensuring that, it's internally consistent and won't break itself. And yeah.
Okay. Well, that sounds great. So having said that, thank you all very much for participating. We're ending a little bit early. I look forward to seeing you guys offline. And sorry that our venue got canceled at the last minute and we all had to join online. But these things happen sometimes. And thank you again. And have a wonderful day.
Thank you for allowing us the
I
opportunity to
enjoyed
be
it.
here. Yes, well,
My
Nice to
absolute
meet
pleasure.
you.
Nice to meet you as well. Take care. Bye.
Bye, Mr. Williams.